Okay, so welcome.
Thank you. Hi, everyone. Thank you so much for having me here. So first, I have to disclose that I'm primarily a researcher kind of scientist, and I very rarely give presentations. But recently at a conference, I gave a presentation, and when it was uploaded on YouTube, it got a comment that hit me. So I decided to use that comment as the subtitle of my talk. And it was, it's almost criminal that this information is not more known and talked about. I don't think the slides are moving. Okay, thank you. So the comment was that it's almost criminal that this information is not more known or talked about. So first, I have to disclose that this information is not a medical advice. I'm a co-founder and co-owner of Ketone Technologies and founder and owner of Audacious Nutrition. I have several patents connected to ketones that the University of South Florida owns. And first, we're going to talk a little bit about several, my early experiments of ketones, about neuroprotection and neuroregeneration, how ketones can help metabolic health, and how ketone metabolic therapies can help comorbidities that are present with obesity often. I'm going to cover some of the key mechanisms, and we will go through a couple of the safety and efficacy details about exogenous ketones and the common misconceptions too. So first, what is metabolic health? It's basically a physiological state when the body and the organs function properly, which will eventually reduce the chance for chronic diseases and other diseases such as cognitive decline, diabetes, cardiovascular risk, and stroke. So basically, that's the goal. That's the target, right? So my early experiment, I started working with ketones when I got involved studying central nervous system oxygen toxicity seizures. So this study was funded by the Office of Navy Research, and they wanted to know how to prevent and predict seizures that Navy SEAL divers get when they breathe 100% oxygen underwater under pressure. Not only Navy SEALs are affected by this problem, but also people who are undergoing hyperbaric oxygen therapy. So to simulate this scenario, we used hyperbaric chambers and also rodent models to try to develop something that we can give acutely to basically protect the brain from oxidative stress-related seizures. So prior to 1960s, it was thought that the brain can only use glucose for fuel. In the 1960s, they did a study at Harvard where they fasted people for 40 days, which you probably couldn't do today. But what they saw is that the blood glucose level went down and blood ketone level went up. And what they saw is that the brain used approximately 60% of the energy from ketones, ketone bodies, primarily the molecule called beta-hydroxybutyrate, or BHB ketone. And even if they reduced the glucose, blood glucose level with insulin even further, the ketones preserved the brain energy metabolism, and they were completely asymptomatic. So what is a BHB ketone? Basically, your body can make BHB ketones by itself, or they can also like, for example, when you're fasting or you follow a carbohydrate-restricted diet, but you can also take it as a supplement, and I will talk about that later more. It's not the same as ketoacidosis, so some people are concerned, but it's not the same. Nutritional ketosis is safe and healthy. And basically the idea is that these ketone molecules can with these ketone molecules, the cells can generate more energy than they could do with glucose. So based on this idea, we started using different ketone supplements and combinations of different ketone molecules, and we found that some of these combinations actually delayed the latency to seizures in these studies. So that was good news. And a couple years later, my husband and I became involved in the NASA Extreme Environment Mission Operations, which is, it's called NEMO mission, which is basically a space simulation mission. And astronauts are trained to test different procedures, equipment, to test before they go up in space. And the goal is that they put these crew members to high stress, high workload conditions and environment and measure different outcomes. Since these missions took place underwater, in an underwater habitat, in order to come back to the surface, we needed to breathe 100% oxygen underwater under pressure. So we became a study subject there too. But CNS oxygen toxicity is not the only challenge for the brain, for the crew members during these missions. And first I want to talk a little bit about healthy brain and allostatic load. And allostatic load is basically the impact of chronic stress on the body. So in 2017, my husband was invited to be a crew member on this mission, and I was selected to be one of the lead researchers on studying psychological and physiological changes during these missions. So I had to train the crew members how to do the experiments, and I had to make sure that they are doing the experiments properly. So I was supervising my husband when he was in the habitat. I was also supervising during EVAs. These are extravehicular activities, basically simulated spacewalks, and also from the mission control. So one of the experiments we used an iPad, and basically they had to touch the screen as fast and as accurate as possible when something appeared on the screen. And to make this experiment consistent, they had to remove the gloves during the EVAs. So when it was my husband's turn, he forgot to remove the gloves. So I was a little bit angry that he didn't listen to me again. But so we had to repeat the experiment. But as the mission went on, we found out that no matter how many people, how many times reminded the crew members to remove the gloves, they most of the time forgot it. So it started to be suspicious that something is going on with the cognitive function here. And indeed, the brain is a very energy-demanding organ. Approximately 20% of the calories are used by our brain. And when there is acute stress, we will have increased stress hormone, which will increase blood glucose level, which will increase the glucose uptake in certain brain areas to prepare us for fight or flight response. But when there is chronic stress, it's basically the opposite. So certain brain areas, glucose uptake will be decreased, and this can lead to memory and learning cognitive function problems. So I guess most of you had experienced chronic stress in your life for whatever reason, but unfortunately, the chronic stress can accelerate aging at a cellular level, and it can lead to the metabolic diseases that we want to avoid. So what can we do about it? Basically, when there is when the brain's metabolic health is compromised for any of these reasons, for example, chronic stress or neuronal injury or neurodegenerative diseases or just aging, there is a glucose, cerebral glucose hypometabolism, so the brain can't use the glucose as well. But the ketones can serve as alternative fuel in these scenarios. So basically, BHB is a mitochondrial fuel which increases energy production in the cells by approximately 25% compared to glucose. And not only that, but it will also increase mitochondrial biogenesis. So you will make more mitochondria to help replace the aging and damaged mitochondria as well. So what happens with the aging brain? The metabolic health of the aging brain has a similar scenario. So basically, there is glucose utilization impairment as we age. Our brain's ability to use glucose will decline. So as you can see on this PET scan, there is a normal brain on the left, and you see that it's very intensely using glucose. But on the right, the brain with Alzheimer's disease is not able to use the glucose that much. So if somebody has a poor metabolic health, that will lead to worse brain health. And since the brain can't use glucose, there's going to be an energy deficit in the brain, which will lead to cognitive decline and eventually Alzheimer's and Parkinson's disease. But the good news is that, again, BHB ketones can restore this brain energy metabolism. So there was a recent study where they showed people with Alzheimer's disease on the left, you will see, have decreased glucose utilization in the brain on the bottom. But in these same areas on the right, you see that there is increased ketone utilization. So basically, the good news about this study is that this shows the presence of viable glial cells and neurons. So the cells are there, they are not dead, they just can't use the old fuel anymore. They need to upgrade to a new kind of fuel. So this is about an interesting accidental discovery that I worked with laboratory rodents, and I put them in an anesthesia chamber so they are not so worried when I take their blood. And I noticed that the ones that had high blood ketone levels, they just didn't go to sleep. The control were still like long time sleeping, but they didn't go to sleep in the anesthesia chamber. So we designed an experiment specifically about that. And it turned out that it looks like the BHB ketones can increase the resistance to anesthesia. And not only that, but probably other harmful gases too, which can be important, for example, for firefighters or military. And another accidental discovery happened when I was working with laboratory rodents, again, with using this equipment. It's called a rotarod. So basically, a rod is spinning faster and faster, and they have the instinct or fear of height, which I can relate to, that they just try to stay on the rod as long as possible so we can measure their endurance after giving them different ketone supplements. So what I noticed is that when those animals that got different ketone supplements, they looked down and they just didn't care, they jumped off. So we designed a specific experiment about anxiety, and it turned out that the elevated ketone level actually helped reduce anxiety as well. And also it improved endurance, and you can read more details about it. I'm not going to go into details. But another important finding came out from this study, that the BHB level not only increased, but the glucose level also decreased. So either if the animals were rested or if they exercised, the glucose level went down. So this is going to be important. I'm going to talk about it a little bit more later. So 10 years after this experiment, more and more research is coming out, and more anecdotal stories are coming out too, that people who are in ketosis, either with the diet or with ketone supplementation, they experience therapeutic effect in psychiatric disorders, different psychiatric disorders. For example, bipolar patients or autism patients also reported improved outcome. And as you can see in depression, it's very similar, the brain scan. Basically, the brain's glucose utilization is impaired. And since then, there's a new scientific field that evolved from all this research. It's called metabolic psychiatry, and it's growing rapidly. So one of the mechanisms by which ketones can have anti-anxiety effect, it's basically that they can modulate the neurotransmitter balance. So basically, BHB will increase GABA, which is the calming neurotransmitter, and reduce glutamate. The outcome is improved mood and calmer brain. And this is the other very exciting experiment of my career about brain injuries. So when there is a brain injury, the brain will experience some metabolic abnormalities. There's going to be a high energy demand to repair the brain, and it can have an energy crisis too in the brain. So what happened in this experiment is that I grew brain cells in a Petri dish, and I scratched the Petri dish to simulate injury. And I followed what happens over 24 hours and took pictures every 15 minutes. And what I saw is that those cell cultures that were treated with BHB ketones, the cells basically migrated into the damaged area, while in control, nothing really happened. So this is the control slide. So basically, this is over 24 hours. You see that nothing really happens. The gap is still there. And the next video is going to show the slides that were treated with BHB. As you can see, the cells started to go into the damaged area and move around like crazy, starting to grow processes. And in 24 hours, they almost completely closed the gap. So this is very important for anybody who has brain injuries. So how many of you know anybody with a concussion or traumatic brain injury? Yeah, so almost 80% approximately. So the good news is that we reviewed approximately 50 studies, and it shows that ketosis significantly reduced mortality after different kind of central nervous system damage compared to glucose-based interventions. And there was also another study that exogenous BHB improved the outcome after traumatic brain injury. And stroke, unfortunately, the statistics is not very good. So about 1 in 4 of us will have a stroke in our lifetime. But again, more and more studies are coming out that, for example, in a rodent model, they used ketone salt in a stroke model, and it improved the neurological outcome. And there was another study where they used the combination of the ketogenic diet and exogenous ketone salt in a spinal cord injury, and that improved outcome too. And to leave the brain behind a little bit, I wanted to talk a little bit about hormonal regulation and appetite regulation with BHB. So there is not too much study on this topic, but what we know is that ghrelin, the hunger hormone, is basically suppressed by BHB. And the reason is that because BHB is an energy molecule, it signals to the hippocampus that we have an alternative fuel, so we don't need to take in more energy. And the other hormone, leptin, is the satiety hormone. Again, very, very little data available, but what we see so far is that BHB may enhance leptin sensitivity. I have to speed up a little bit. So we also see that BHB can improve insulin sensitivity too, because it increases glucose uptake, reduces inflammation. And yeah, I was mentioning this. So based on all these hormonal regulations, and also because it improves the blood sugar control, we will basically have less cravings, more satiety, and that will eventually lead to weight loss. The BHB itself doesn't burn fat, like many people claim, but because of these effects, it can lead to weight loss because you're just not going to be hungry as much. And some of the comorbidities that also major health concerns that appear with obesity. So for example, if you're a woman, sooner or later you will have perimenopause or menopause. And if you have bad metabolic health or people with obesity, they will experience these symptoms even worse. And the symptoms are problems with managing the weight, electrolyte imbalance, brain fog, difficulty concentrating. So these are all things that we mentioned that the BHB ketones can support these symptoms. The other very common comorbidity is cardiovascular diseases. Recent studies are showing that BHB can reduce the resistance that the heart has to pump against, basically. So with this, it can improve the heart's efficiency. The other positive effect, like if we end up losing weight, sometimes the weight we lose is from muscle. Well, studies show that BHB will help spare muscle protein breakdown, so you can preserve the lean muscle while you are losing weight. And since I mentioned that BHB is an energy molecule, it's not only an energy molecule, but it's also a signaling molecule, which will help to upregulate genes involved in antioxidant defense and also other longevity-associated genes. It will also help reduce oxidative stress, so there will be less reactive oxygen species in the cells and helps to eliminate reactive oxygen species. Naturally can increase NAD+ and also glutathione. Studies also showed that it can enhance cerebral blood flow by about 30%, so that's good news because your brain is going to get more oxygenation and more nutrients, and like I said, it lowers blood glucose level, and for example, it can be very important after a traumatic brain injury. It also stimulates BDNF production, and BDNF is basically a molecule that can help to develop new connections in the brain and also to repair the brain after injury, and also very important role during learning and memory. But it's very low, for example, during stress and in people with depression. And the other important mechanism is that BHB was shown to reduce inflammation in several pathways by inhibiting the production of inflammatory cytokines and many other pathways. So since inflammation is contributing to many, not only the neurological but systemic diseases, that can be also very important. So by now, everybody is probably wondering how can we elevate blood BHB levels. Well, we have a couple options. So first, one option is that we can do water-only fasting, but there's only so much you can fast. You have to stop at one time, right? So you can't fast all the time. And once you stop fasting, your ketone level is not going to be elevated anymore. The other option is you can follow a high carbohydrate diet or ketogenic diet. But for many people, it's difficult to know what they can eat and what not. Sometimes they can overeat calories. Sometimes, for example, older people, they don't want to change what they want to eat. They want to eat what they want to eat. Or, for example, kids too. So what we see that most sustainable for most people is basically doing a low-carb diet. So you reduce your carbohydrate intake, so you prevent the glucose spikes, but your body is still not going to make ketones. So then you can add an exogenous ketone supplement on top of the low carbohydrate diet, and you can dial your ketone level as high as you want whenever you want it. And so I wanted to talk a little bit about exogenous ketone supplements because there are big differences. So they are not the same. There are a lot of products on the market, and there's a lot of misinformation also on the internet. So I wanted to make sure to point out a couple red flags. So for example, when they say it's a proprietary blend, it probably means that they don't want to disclose how much actually active ingredient is in the product, and it's probably very low. Sometimes they claim there are ketones in the product when it's actually a ketone precursor. It's not a ketone molecule. You can see on the top what is exogenous ketone and what is precursor. Usually ketone pills or gummies just have very little amount of ketone. It's not going to do much. For example, many companies put a lot of caffeine in it or other stimulants. Then, of course, you will feel a lot of energy, but it's not because of the ketones. It can be from the stimulant. So these things that you need to be careful about. So one of the very common ketogenic precursor or pre-ketone is the medium-chain triglycerides or MCT oil or MCT powder. This can elevate your blood ketone level a little bit. If you if you take more, then most people experience diarrhea, and it can also lead to high calorie intake. While 1,3-butanediol is also a ketogenic precursor, not a ketone. Some companies claim as ketone ester. It is not a ketone ester. Technically, it is an alcohol as a diol. So basically, it has to go through the same pathway like alcohol. So your liver has to break it down through the alcohol dehydrogenase pathway, which will put pressure on the liver. And it can be mildly narcotic too, so we don't recommend it to older people, and it also tastes very bad. The other option is free BHB acid, which is very unstable. So, and it also increases blood acidity, which is probably not very good for example, cancer patients, because the acidity can drive metastasis. Ketone esters, also very potent to induce ketosis, but the same thing here. It puts pressure on the liver. It has to break it down the same way, and it causes nausea, dizziness in many people, and it can increase insulin as well. So ketone salts are basically the BHB molecule that is ready for your cells to be used, combined with electrolytes. So usually this doesn't increase insulin. It can be formulated to taste good and doesn't put pressure on the liver. But most studies are focusing on only acute dose. So we wanted to see what happens if people are using these supplements longer term. So for example, we did a study for 4 weeks, and we saw that the ketone ester and the 1,3-butanediol had negative effects on the liver. The MCT and the MCT ketone salt mix had intermediate effect. There was some lipid accumulation, and the ketone salt group had completely similar histology in the liver like the control. So for long-term administration, that seems to be the best option. And a couple misconceptions that people hear very often. So for many years, people, and still these days, people are chasing higher and higher ketone levels, but we see that for most applications, the 0.8, between 0.8 and 2 is the best range of ketones, because if you elevate it further with, for example, with ketone ester, you will increase the insulin, which you don't want. Another common misconception is that only DBHB is bioidentical, which is not true. Both the D and the L version of the BHB are bioidentical, but the ketone monitoring devices can't measure L, they only measure the D, so you have to keep in mind. And also when they administered both D and L, they found that the L goes also to the brain and the muscles, while the D didn't go, the concentration wasn't elevated in those tissues. So if you want to address anything brain-related, you have to make sure that the L-BHB is there too. People are concerned sometimes about too much salt in ketone salt. Well, actually, sodium chloride is not the same as sodium BHB. Sodium chloride is the kitchen salt, which can elevate blood pressure, but it's not the case with sodium BHB. People think that everybody should react the same way. That's not true either, because the effect will depend on age, gender, muscle mass, stress level, activity level, and a lot of other different things. So basically, based on all these cellular, molecular, and systematic benefits, we can see that we can improve our weight management, the comorbidities, and in general metabolic health. I said that. So in 2019, I was invited by NASA to be a crew member on the next NEMO mission. And we had to do some of the same experiments. So I was happy that I know what to do. And this is me waiting for the green light to go out on a simulated spacewalk with my iPad to do the task that I needed to do. So this was a 5-hour-long EVA, and we needed to solve a lot of very stressful tasks. And before going back to the habitat, I had to do the cognitive experiment too on the iPad that previously the other crew members had to do. So can anybody see what's the problem here? So, yes. So high workload, cold water for 5 hours, high stress environment, and I forgot to take my gloves off. My brain failed me. So basically the lesson here is that at some point, everybody's brain might need some extra ketones. So I will be at the Audacious Nutrition booth if you have additional questions. Basically, the government realized that they spend a lot of money on academic research, a lot of good results coming out, but nothing gets put back to the public. So they established a program to train academic scientists to create companies and products so the public can actually benefit from it. So the University of South Florida pushed me into this program, and I created Audacious Nutrition so everybody can enjoy the benefits of these molecules. Thank you.